Hello. The purpose of this video is to demonstrate the use of the DTIM-lite tool. The DTIM-lite tool is a spreadsheet that is designed to help users define the inventory tables that they want to use for their forest inventory. This helps avoid a situation where users are asked what they want. They say they want to measure everything, except some of that information is never used and it ends up in the garbage. We want to use the DTIM process to select a small number of things to measure that are going to be useful. So in order to use this tool, the first step is to examine the structure of the tool. There is a tab for setup and instructions that explains how to use the tool. The main tool is found in the Metrics and Grouping Variables tab. There are columns A through E which have information that does not change. The user enters information in column H and then make selections from columns I, J, and K, and L. So let's say we begin with a blank tool. We might say, we need information on biomass. That's not acceptable for a monitoring question. What we need you to enter in column H is a very detailed explanation of what you need. So for example, we need information on how much biomass can potentially be provided within the forestry units. The unit directors must give a report to the national government, which uses this for international reporting. So the first thing we do is we say we have to choose a metric. When we choose a metric, there is a menu here where it has a list of all of the metrics. You see a long list of metrics here that are found in column B. In other words, column B provides the list of metrics that we see over here. So I know that I want to have information on biomass. One of the metrics in column I is above ground dry weight of live trees. You might have a slightly different definition of biomass. For example, dry weight of merchantable bole, which is just a forestry term. There are many, many other metrics about area and number of trees and area of land, mortality, growth, harvest removals, carbon, etc. For our example, we will choose just biomass. So these grouping variables, when we produce a forest inventory table, it's often not just one number. The table is arranged in rows and columns. For example, I might want my above ground biomass table to be divided by land use and by distance to road class. A distance to road might be 0 to 100 meters, 100 to 500, and greater than 500. That variable might be helpful because if it's more than 500 meters from a road, we're simply not going to harvest it because it's too difficult to get the wood to the road where it can be taken to the mill. There's an option for a third grouping variable here as well. So in this example, since we're interested in potentially harvestable biomass, we choose biomass as the metric. We choose land use as one of the grouping variables, and you have many choices. These grouping variables are found in column C, and these have a name, because column C and D, and the name is in column D. And by using the drop-down menu, we can make these selections, and it provides for us the name of the inventory table that our inventory will be able to report. So in this case, the table, based on the selections I made in columns I, J, and K, and I left column L blank, is above ground dry weight of live trees at least 1 inch in diameter in short tons on forest land by land use and distance to road. So you could imagine this table will have land use as the rows and distance to road category as the columns. And the cells in that table will be the biomass for that combination of the row and the column. Finally, in column N, there is an additional place to enter information. The request is that you enter the precision requirement and geographic scope. So for example, this information should be at the national level. If you wanted the information at the unit level, you would just change that to information at the unit level. And we want a 10% sampling error, confidence interval, at the 95% level. So we know the name of the table, we know what we have to collect in order to build that table, and we know specifically how that information will be used, and we know how good, how precise, how good the confidence interval has to be for that estimate. We can do a second example here. I might say, I want, need to know the total amount of forest by forest type by unit. So the metric I need to, for that information that I need is the forest area. So I look through my metrics and I see, aha, area of forest land. I know that I want that by forest type, so I look through my grouping variables here for forest type. I'm sure I have it in here somewhere, forest type, and I might need it by estimation unit. So I might not have a unit, but I have something called survey unit here, and we'll use that. So as we can see, we have created a table that is the area of forest land in acres by forest type and survey unit. And here I can say the 95% confidence interval must be 25% of the estimate. And that's just an example of how I might describe the precision requirement. And I might say this must be at the unit level. So now when I save this file, what I have is a memory. I have a library of all of the decisions I made about what my inventory is going to be used for. Here are the justifications or the motivation behind the inventory in column H. Here I've chosen the metric and grouping variables. Here I have automatically produced the name of the table that I plan to produce to answer this monitoring question. And here I have some more detailed information about that table, about the confidence interval, about what geographic level I want it to be at. By filling this out, you will have a very useful planning tool that documents all of the decisions you made to conduct your inventory.